Welcome to Unit 4 of our course Procedural Programming. And this unit we will deal with aggregate data types. So what does this mean in detail? We will talk about enums and structs. Structs you know already from C#. Enums is a new concept. Next we will do again a little bit things with arrays. Arrays are well, we had this already, but we go one small step further such that we really understand what is going on behind. And finally we will again deepen our knowledge about the relation between arrays and pointers in C, and then we will finally look into how efficient an array access really is. Okay, since this is again a quite big agenda, the whole unit is split into 3 sessions. So Enums and Structs will be the first session. We're doing in this video. Another video will treat arrays in more details, and finally in a third video in session 3 we will discuss the relationship between arrays and pointers and the efficiency of array access. Okay, let's start with session 1 and with enums and structs. Good. What are enums? So imagine a situation we have a fixed number of identifiable labels. So for example, in a TCP connection, the TCP connection can have different states. It could be new, if we create it. It could be established if we have an open link, or if it could be closed. Another example could be even a Boolean data type. It has 2 clearly identifiable labels, namely true and false, or days of week, month names, etc., etc. There are lots of different possibilities. So how can we do this in C? So for example, we take the days of the week, and we say, okay, we define a data type enum weekday, and this data type accepts 7 different values, namely mon, tu, wet, the, fry, set, and son. And yeah, you can easily see that these are the days of the week. And yeah, and so we have to define such a data type. We have to write down the keyword enum. Then we give the type name, how we want to call this type, and then we have the so-called enum labels. And then so when we have defined this, the next question is how can we use it? And so okay, we just assume here a main function, and we declare now a variable with the name w, and we declare this w to be of type enum weekday, and we assign it, we give an initial value to w, namely the label Thursday. Okay, so this is the one thing. So we can, so w is now a variable which can accept different values out of these labels we've defined here. And even more, we can even iterate over such a variable. We could say, okay, for I, which is of type enum weekday, starting with 1 and ending with a sun, we iterate over these values. So this means implicitly we have an order here, and we could say that the Monday is smaller than Tuesday, etc., etc. This is sometimes pretty convenient. So to make these things a little bit clearer, we are doing a programming session here. I will do a very simple. I will show you a very simple month printer, which shows how we can use enums. Good. Let's go to our editor. Okay, enlarge this a bit such that you can see everything. Okay, something like this. Okay, good. Sorry. So let's start in a new file. We call it monthprinter.c, and yes, of course we need something to print out, so we include standard io.h, and we will have a main function like this. Good. And I just want to show you how we want to use that. So in the main function, we want to write down something like, I have a data type enum month, and the variable should be called month, and I give it just the label March, and then I print month. I want to have some function print month where we write down where we pass our variable month. And finally, I also want to show you the iteration. Month is equal to January, m smaller equal to December, and m plus plus here, and then sorry, it's a print month m. So yes, okay, this is what we want to have, and first then we start stating the prototypes, because you know, in C we have to write down the signature or the prototype of the functions we use. So print month is a function we use in here, and the signature should be something like okay, void, because we don't return anything. Then it's the name print month, and then we are passing a variable of type enum month. So looks like this, yeah. And finally here we could just take this one and oops, sorry. So, and we have the month. So we have the function. This is the implementation of this prototype here. Okay. Then we finally come to the significant point here. So how do we declare months? And this is as you have seen already in the in the slides. We have to write down it's an enum, and we call it months, and then we have the curly braces here, and now we state the labels. So February, March, April, May, June, July, August, September, October, November, December. Yeah, so okay, we have it here. So this one is the definition of the data type, and here we are using that stuff. So we should be at least in a compilable state, although we did not implement here print month already, but we just check out whether we can compile and link this. So you maybe remember GCC -o month print -w all -pedantic -standard is C99 and month printer.c. Yeah, and it works. So it compiled and linked without any errors or warnings. Okay, then, but of course it doesn't do too much because we did not implement anything here in the print months. So we are, what shall we do here? We have 12 different labels, and depending on that label, we have to write something into the shell. Of course, the most or the best fitting construct here would be a switch. So we switch on based on the value of month, and here case Monday print. No, sorry, Monday, wrong. January, the new line, break, case, February, and so on. We will not continue until the end, because here things would get pretty boring. Okay. Sorry. Okay. And so February, March, April, March, April. So this is at least something, and now we do the following. We don't go until December, we just go until April, and then we're done here. So save, try again. Okay, yeah, we get a warning here. This is very kind of the compiler, because it says, hey, you have 8 enumeration values not handled. This means from May until December they are not handled in that switch. So this is of course not fine, but okay, it would get a bit boring, but we could somehow handle this in the way writing down here default printf some strange month. Oopsie. Break. And then here we could go back to December. Try again. Yeah. And it compiles without any warning. So, and now we could start to the program, and you see, okay, we have March. First it prints March, of course, because we have first we print month, the variable month, and this was initialized to March, and then we iterate over all the values, and it then writes down January, February, March, April. And since we did not specify all of these labels here, the rest is handled via the default branch of the switch. But okay, you see that it would work, and how it would work using enums. Good. Now let's go back to our presentation. Good. So we have shown you how enums could be done in C, and you have seen this in this programming session. And yeah, there is one final question left, maybe, because you already know symbolic constants, and you could say, okay, what is wrong with that? If I write down define Monday 0, Tuesday is 1, etc., I could use these labels, and I could do pretty similar things, or the same things as doing with enums. So why on earth should we have a new concept with that? So yes, that's true. So there is nothing wrong about symbolic constants, but we have one thing, and this is again a little bit about clarity and self-explaining source code. If we have a general symbolic constant, the underlying data type is open. This means it's an int or a character or whatever. So compare the two following lines of code. First, we use int workday. This would be the line of code if we define symbolic constants, and then we could write down workday equals, or is so the Monday, the label Monday is assigned to workday. Or if we use enums, then we would have the following line of code. We would have here enum weekday workday. So we would the declaration of the variable would be much clearer, and would show the reader a much better idea what is behind the workday than this one. So this is the reason why enums are quite useful, and can help you to make your source code better readable and better understandable. Good. So we're already done with the enums. Now we go to the structs. This we can really, over this we can go quite quickly. So you know structs already. We have so we have a collection of data having different data types. For example, the date, a month, and a year. A day and a year, which is basically are integer values, and month could be, for example, an enum. Or a person, you have strings, first name, last name. You have an ID, which is maybe an integer. You have a street, which is again a string, zip code, depending on the country where you which you support. It's either a string or an enum or an integer, etc., etc. Yeah, and we need to address the whole record or also parts of it easily. So you know this from C#. Okay, the interesting thing is that how can we use structs, how can we define structs, declare variables, etc. So struct in C, you see it's totally the same basically as in C#. So we have the keyword struct, we have the type name, and we have the so-called members. Yeah? And this is as we had it in C#. The only difference is that we, as far as I remember, we called the members in C#. We said these are fields, but it's the same thing, just two different names for the same thing here. There is just maybe one thing we should consider here. The day, we say it's an int, or the year also it's an int, and we have the possibility here in C to write down that it's an unsigned int, means that no negative values are allowed here. Good, this was the definition of the data type. Now, how can we use it? And there is a slight difference again to C#. We have a variable of type struct date, and here you see we have, again, like with the enum, we have to write down struct in front of the type name, and you remember in C# this struct was not in place here, but the rest is totally the same as in C#. And we could give it an initial value. And how do we do this? We can open a curly brace, and then we write down the different values in the order as they appear in the type definition up here. So first the month, then the day, and finally the year. Good. We could, again, as we had in C#, we could take one specific part of the struct. So d.month, we assign a different value, namely, for example, March. And we could do a very funny thing. You maybe, again, you know, C is something about pointers. And now let's go into this line of code here. We say p_d is a variable of type pointer to struct date. So means pd is a pointer to such a struct. And you know, a pointer is basically an address, and so we could say, okay, we assign it a value, we initialize the pd with the address of variable d. So just very slowly, we have a variable d here, and we said, okay, this has some value. And since we have the variable here, the compiler is finding an address for this variable. We can now access the address of that variable via the ampersand here. And we could say, okay, the address of that variable is assigned to another variable which is definitely an address to such a struct. Good. Now, next line again, very slowly, we take PD, means the pointer, and if we write down here now the star, if we not if we declare PD, but if we use PD and we write down the star has the meaning take the value of the variable PD. So PD is an address, and we take the value where PD points to, and this is basically the address where D resides. And now we take the component day, the member day, out of this variable, and we assign it the value 23. This would mean that now D would have March 23, 2010. Yeah? So because PD is pointing to the same address as D, or to the address where D resides, we are so we can change the value of D using PD. Okay, and now we have the last line of code, and we have again a bit something different. This means we take here PD again, you know, the pointer, and here we have this arrow year. And what does this mean here? This is basically here, this is the same as here, but here it's a shorter way of writing. It's simply, you can now remember this. If you have this arrow, it means that we have a pointer here and we want to access a member of the struct where the pointer points to. So this would mean if we are here now in the execution of our program, these values here would be March 23, 1967. So these two again, these two constructs have the same meaning, but this is the usual style, and we will use this. We use the arrow notation. I've shown you this one only because it's directly understandable out of the pointer notation of C. And if you see very old C programs which were programmed according to a standard of the early days of C, you could even see such constructs here because this arrow notation was introduced in a later standard. So this is a good time to go to another programming session and to see how structs in C work. Good. Jump over to our editor. Increase the size a bit, and maybe a little bit more. Okay. Now we could start. We add another file, data printer.c, and this is where we start. Of course, we could reuse parts of the month printer. We could use everything here because we would need it anyway. When we print the date, we have to print the month, so we of course don't reinvent the wheel here. Okay, December, up down here, copy, and yes. So we have the prototype, we have the implementation, and okay, we start with the main function, main int argument count, pointer to character, argument vector, and this is a vector, of course. Here we go. So I just show you what we want to have. I want to declare a variable maybe called start, and it should be of type struct date, and I assign an initial value where we say it should be, I don't know, just say October 15, 2014. This is what I want to do, and then I want to call a function print date start, and this should print this date in a English style manner. So what do we need here such that to become compilable as soon as possible? We need the struct itself, struct date. Okay, in C we need a semicolon at the end, as here, of type definition. So we define the type here, date. The struct date should have first it should have the enum month, then we have an unsigned integer day, and then we have an unsigned integer, oops, sorry, year. Exactly. So we have the type we used here, we have it defined now. We have we need a print date, prototype first, print date, so means this doesn't return anything, it's called print date, and we pass struct date. Okay, and for the implementation, I start over, or I go into here, because you could imagine that we'll need print month when implementing print date. So just give me 1 second, because we have already quite a good bunch of code. Just give it a try whether we can compile print, no, maybe date print minus w all minus pedantic minus, oops, standard is C99 date printer dot C. Okay, good. So it compiles, and so we can start implementing the print date. What do we have to do? We want to have some output, like maybe today, date, maybe something like this. Date is October 15, 2014. Yeah, something like this. This is what we want to have. So what do? We are we are getting the date here. Sorry, this is here, we get the date. And so since we accept exactly one struct here, and this is really the struct, we can simply do the following. We have, first of all, we need a printf. Date is blank. So the point simply is that print month prints the month itself. So we call print month here, and we have to pass a month, and this is date dot month in our case here, because we are getting the full struct date, and we only refer to the month, to the member month of the struct here. Exactly. And then we could write the rest, and this is 2 digits, zip, the day, followed by a comma and another D, the year. And we say we take date dot day and date dot year to be printed. So then we have one slight problem, because we have these new lines in here. We have to remove that because otherwise we would get the new line into here. But you know, implement a little, test a little. We first try to compile it. It works. There is no compile error. And yeah, so just date printer. Date is October 15, 2014. So yes, you see we have some problems with the new lines here. I'm adding a new line here to make to have the prompt here in a real next line, and then yeah, okay, we have to do stuff like this. Okay, this is 99% reuse. Okay, but you know, new line, new line, new line. Okay, and now it should be fine. Compile again. Whoops. First compile. Now call it, and oh, you see we have another slight problem, but I think it is easy to fix. Zip. After printing the month, we add a blank, and now it works. Good. I just show you one final thing here, because you have seen in the slides that we could also we could define or we could declare a pointer. So we do the following. We say we have variable p_start, and this is a pointer to a struct date. Okay, and so this means this will contain an address, and we have to assign a value, so which address it could be. And we say simply, okay, it should be the address where start is residing. So we know at some address there is the values of start, and we can access this address via the ampersand. And so we could say we take the address of start and assign it to a specific variable which is a pointer to a struct date, since start is a struct date, so these two things should fit together. And now we could do the following. We could say p start, for example, month equals, okay, just take something, May. And now, just to check whether this really works, we type again print date, p start, compile it. Okay. Yes, of course. Here we have a problem now. Just go through that. We got, while compiling, we got the following error. Passing struct date star means passing a pointer to struct date to a parameter of incompatible type struct date. And you see here, print date is accepting a struct date, but it is not accepting a pointer to a struct date. But here p start is a pointer to a struct date, so this wouldn't work. What we can do is we could dereference, means take the value of the variable of the address stored here in p start, because again p start is storing an address to a struct date, and if so this means the star here is indicating that p start contains an address. And if we use this address, we could say, okay, we are not interested in the address, we want to have the value, and here we take the star to dereference, we call this dereference, the address to a value. Good. Give it a try. Now it works, and you see it's now May 15, 2014. But there is another interesting thing, because we said that print date start. So what would happen here if we print the date start? So just go through it. What can we expect from our test run then? Because p start is pointing to the same values as start has, and we are changing the month at the address where p start points to. Also start should have the same value as p start, so this means we could change the value of start, or the values of start, via the pointer p start. So this means if we now compile and we execute this one, we should have the same the same date, namely the 15th of May here and here. Give it a try. Yeah, as expected. So this is how we are dealing with structs in C, and another small idea how pointers work in C. And yeah, that's it. We can go back to our presentation, but there isn't too much left. Just give me one thing. Yes, okay, to have the focus back here. So we have seen the date printer, and we can go to the first summary, and means that the first session is already over. You just go to repeat what we did. You are now knowing, and you can apply enums, and just to give you a basic idea back how we do this, we have enum for example, game state, and the different states here as enum labels. And second, you know something about structs, and we were already dealing with different fields and different members and stuff in the struct. Good. This is now the end of session 1. Hope you were able to follow all the stuff in here. And yeah, if you have comments or suggestions, don't hesitate to write it down in the comments. And yeah, I hope to see you soon with session 2 of Unit 4.